Hey guys, welcome back to the trading session, trading signals coding session, episode 19. Um, Today we are going to resume our work. Remember, we were disassembling the first iteration of trading signals that was already working, and we are moving towards the second iteration, where instead of sending every signal through the peer-to-peer network, we are going to send only the file key. That is a file that we're going to store somewhere on the internet using the OpenStorage project that we created several days ago. So at last episode, we did all the workflow that happens for on outgoing signals. So today we are going to work on the workflows of the incoming signals. So let's jump into the code. I'm going to load the workspace for this, that is Trading Signals demo. And we will be using one of these workspaces. Okay, this one, task server number 1. Okay, so to recap and refresh our memory, what we had is here this module outgoing signal, the one that is used for every signal that need to be broadcasted from the trading system, comes here. After creating this message, it is broadcasted here, and is going to outgoing candles, which is this module that we created the last episode. That what this module does is going to accumulate all the signals by social trading bot and candle. So all the signals belonging to one candle and one social trading bot are accumulated. When we have one candle complete worth of signal, we are sending it to the OpenStorage project, and that jumps into here. This persist that is going to accumulate these messages with a candle worth of signal by trading bot, by social trading bot. So it's going to accumulate it, and every 1 second for now is going to save one of these files at whatever storage is configured for that social trading bot. This could be a GitHub repository, for instance. So the file is encrypted, a hash is calculated, and all of that is what we call the file key. That is what is needed to locate the file on the open internet, retrieve it, decrypt it, and then use it as signals. So we are sending this in this way, broadcast file key, that is coming again here, broadcast file key, to this module that is for trading signals, where it's going to be signed by the social trading bot and the user app this we are using, and is finally going to be sent to the peer-to-peer network via this module that represents the start of the network graph. Okay, so This is the workflow, the outgoing workflow that we developed the last episode. So now we have to go like backwards where we get the information that is coming, that is here. This is the module where the peer-to-peer network sends this message that we will call a signal message. Okay, and this outgoing candle is producing a signal message. The signal message is the one that contains the file key plus broadcaster information, the social trading bot broadcasting this, and the app that is being used to broadcast this, plus the signatures. Okay, so all this message exactly like this, once it goes through the peer-to-peer network, that is a pending task of things to do. Will end up arriving. Where was it? It will arrive here. I will remove this. We don't need it. We don't need this guy either. Okay, so this will arrive here because this is part of the incoming workflow. Incoming will come from here to here to here. So the message, any message coming from the peer-to-peer network into the application is coming through this interface. So this message could be events or it could be signals. Event if somebody follows somebody else. Okay, that's not our problem. But when they are signals, then they are going to be routed towards incoming candle signals. That is a module that we created last episode, and is this one. So here is at this space is exactly where we left this last episode. So let's continue. What it says here. Okay, so we receive the signal message, which is the one that is produced by the counterparty of this module, that is the outgoing candle signals, this message. Okay, so from this message, we have the file key. So it is signal message, file key. Signal message, file key. Okay, so we will need the OpenStorage module, this guy, to execute a load file. Okay, to execute this. So to do that, this is the way we get that module, the OpenStorage. In fact, it should be called OpenStorage Client because OpenStorage is the project. So we will refactor this right now. Before start modifying stuff, I will make sure that I have a clean start from the Git point of view. So I'm loading the GitHub desktop here. Okay, I'm going to put it here nicely. So probably these are all the changes that I had before. So I'm going to write here outgoing workflow implemented. That is trading signals, second iteration, outgoing workflow implemented. So we are going to start clean. And now I can do this small refactoring from OpenStorage to OpenStorage Client, because this is the name of the module. Yeah, it is a client because someday we will have the OpenStorage application, the SuperAlgos one, that will run an HTTP server that will allow you to store files in whatever service you run it. Okay, so for now we will call it like this. So this means that I can take this and put it here and execute the load file function, sending the file key I received via the peer-to-peer network, and this is an asynchronic function that is going to go and load the file with this file name, file path storage. But I don't think I have implemented here the decryption, because the encryption was built afterwards. So what I'm seeing here, that I will have to await this, and here we'll get the file content. We need this function to be asynchronic, and maybe here we don't really need this to be awaited, because we don't really care what happened here. So we let it like this, but we will get this file content from the OpenStorage client. Okay, so what I'm seeing here that is missing is that we are encrypting the information when we are saving this, and I don't see that this is decrypted. Here we have the password. So encrypted, decrypted file content is going to be a decrypt of the file content with the password that we got from here. Sorry, it was here. Was already decrypted. So nothing to do. Okay, nothing to do here, even better. So now we have here, we have the file content. What does that mean, and how we plug it into what we have from before? Before we have Before we had this procedure where each signal was a signal message was equivalent to the outgoing signals trading signal message here. Okay. So in fact, I will refactor this because these signals are now called trading signals, but not this one or this one, just the one below. So here we will do trading signal message, and this stays the same. Okay, so we're done there. So I find here we run some validation to be sure that the signal received is okay, is legit. So this goes before this, because at the signal message we have the signatures. Okay, now what is this response message? It's not going to work because this response, let's check this out so that we leave it working well. Validate signature is going to send a response with some kind of problem. If there is a problem, otherwise it's undefined. So maybe what I should do is to capture this. So if response is not undefined, then response message. Good. Okay, then we get the file content. So we get the actual information, and we still need to inject this as a sequence of signals. So we have to unpack this file. So what is this file going to look like? To know that, we will have to come back and study this, because we are creating signal messages that are then sent into here, and these signal messages then are pushed into an array of signal messages, which at some point are pushed to the OpenStorage client. So we have an array of signal messages of, sorry, I cannot continue after fixing the naming, because here we're sending trading signal message, and here it should be trading signal, at least this part. Otherwise, it's going to be ambiguous and confusing. So this is trading signal, and trading signal. And this is a signal message. Okay. So here we are a candle, outgoing candle. Okay. We receive the trading signal messages. We pack them into an array of these guys and send it to the storage. So when we arrive here, this candle signals is already an array of trading signal. So candle signals are also pushed into an array of candles signals. And when we are saving records to save, when we are saving, we are going to save a file that is going to have a timestamp because we want to be unique, even if it doesn't have anything inside. And content is going to have records to save, that is an array of these candles, that is an array of trading signals. So this is the structure of the file object of the content. So the file is going to be stringify. So to unpack this, we're going to do the opposite sequence. Okay, we are going to do the opposite sequence here at incoming candles signals. So the file content is going to be text. So the file is going to be JSON parse file content, and we will get this object. Then, oops. From here we can get the array candles signals, or how do we call this? Records to save, and I will call them then records. No, records, no. Records added, going to be file, content, content is not written well. So we are going to iterate these records loaded. Okay, so each record here is a candle signals. Is a candle signal, and then we're going to iterate that and from here we will get a trading signal message, and once we have one of these guys, maybe we can execute this function um, trading signal message received. That is going to have all these guys inside. Okay. Okay. So now we would be in the same situation. It's very important to have the right naming for me, because this is what allows us to get everything right. So okay, if I call it signal, if If I receive an event here, then I receive a signal here. Okay. Then it is a signal what is going inside. And here we got a signal too. Okay, there it can be a signal message because we are calling it that way when we are creating it. In this case, we're calling it signal. Maybe this is a trading signal. Yeah, it's a trading signal. So we will do this refactoring too. I know that we are using this here. So this is going to be a trading signal. Trading signal. Yes. So here is going to be trading signal. Maybe we did use signal definition. Okay. So we will refactor this by this. Maybe we use this with this timestamp. No, we didn't use it. Maybe we use it with this unique ID. No, we didn't use it. Okay, so the trading signal message is the one that contains inside a trading signal. I like that. Yes. Okay. So where were we? Then this is a signal message. Maybe I will refactor this into a signal, like we have an event. So a signal would be something that travels over the network. The network transports signals, which in fact inside it has a file key and the information is on the file. But it's a signal anyway. Okay. So we are going to call this directly a signal. Signal. So when it comes here to peer-to-peer network start, add the trading signals project. This is a signal, but as soon as we send it to the peer-to-peer network start send message, for this guy, this is a message. Okay, and from here it delivers a message, and that's it. So the incoming sequence, what we have is we receive a signal, and there is a signal received here. So in here we have a signal also. Okay, and then we iterate all this so that we get from there the trading signal message. Okay, that inside the trading signal message there is a trading signal, a source, and so on. Okay, so with this we have connected to the workflow we had at iteration number 1, where through the network we were receiving trading signal messages. Okay, so now I'm not going to go through this because this was working and has a maintenance mechanism, and it has a way to retrieve signals based on the candles and blah blah blah. So we should come back here and reroute this because this is not going to that guy. It should go and get the signal from this guy now. So how do we get that guy? Well, very easily. We will copy this stuff into here, and instead of outgoing signals, it's going to be incoming signals get signal. Okay, and all the rest is still the same. So essentially what we have done is that we have complete the inner workflow by which this is going to be, the signals are going to be consumed by the receiving end. Okay, so we are going to record a commit here. We are talking about the trading signals second iteration incoming as workflow implemented. Okay, so even though I believe that the network should be untouched by these changes, I'm just going to take a quick look to see if everything there is still in place. So we have the WebSocket network client. What do we have here? The HTTP interface is where signals come through. So we have this endpoint, new signal. Here we said that we were going to call this just signal. So signal it will be. What else? This is sent to, not here, incoming signals. Okay, so there is a module called incoming signals. That is this one. That it also receive a signal, not a signal message. Okay. And hold on, because we changed something here. We put signal instead of signal message. And we are sending this guy to the WebSocket interface, broadcast to clients. It's not that one, WebSocket interface, broadcast to clients, message header. So here there is no sign of signal message, and this is sent via WebSockets to all the clients connected there. Okay, so we'll come back here to the peer-to-peer network interface here. Okay, there's one piece missing, one module missing, that is the WebSockets. How did we call this? This is the WebSocket interface. And here, this is coming via also a WebSocket module that I don't see it. Somebody's calling this function signal received. Client interface, signal, no. Okay, who is this guy? WebSocket network client. Yes, probably this is the guy. This is the guy that is actually receiving via WebSockets a message, a socket message. So when it gets here, this message data, event message or signal message. So this is the counterparty to this guy, WebSocket interface here, that this is going to send directly the message header payload that is prepared here. So the payload says signal there, but it should say signal message if we want this to match with this guy. I can see that at events we are calling this an event message. Well, we will fix it, because in fact now it's going to be a signal directly. So it's 100% consistent everywhere. Okay, so this signal WebSockets is sending this here as a signal. So here, by the way, you can see the whole stack. This is the lowest level module regarding communication via WebSockets. Here is where the actual WebSocket message appears. From here, we send it to this peer-to-peer network interface, which handles all incoming WebSocket messages from the, well, not really WebSocket, it can be anything, because this is an interface for the peer-to-peer network. And from here is coming into here. There is a third layer. Okay, this would be the fourth layer. And every module of this have a counterparty. And the other remote application, this the WebSockets client, the counterparty is this WebSocket interface. That is the one receiving the WebSocket connections. And because it has the connection, is the one that is actually able to broadcast information to whoever is connected there. Okay. What I would like to see is where do we have these events? Where are we sending this event message so that I can refactor it with events, but I'm not seeing that now. I'm probably diverging from my mission now, because that's not my problem right now. Okay, I will leave it here. Okay, so last refactoring. Okay, guys, so to recap, at this episode, we have completed the incoming workflow. And as far as we know, all the things are there in order for this to work instead of sending individual signals via the P2P network by using the open storage to store a file, send the signal with the file key, retrieve the file key, retrieve the file, decrypt it, and get the signal out of there. So all the code have been written. At the next episode, I will be debugging all this and making sure that it works fully 100%. And once that done, we would be at the nicer version of these trading signals, and from there we will see. Okay, so hope you like this episode, and thank you for watching. See you at the next one.